Hello, friends. A very happy and prosperous New Year to all of you. I hope you might have enjoyed the vacation and are doing great. So, this particular tutorial is in continuation to my last tutorial, in which I have explained about confidence interval, significance level, what is null hypothesis, what is alternate hypothesis, and all. If you guys have not gone through my previous video, I would request you to please go through it because it will help you to understand what we are trying to do today. So if you and also it's a request that please guys subscribe my channel. I will be posting new videos on machine learning as well as on this particular topics of statistics. And the more the number of subscribers, it will really motivate me to make more and more videos. So do subscribe my channel, like the videos, and okay, let's start. Now, last day, I talked about null hypothesis and alternate hypothesis. So, just to give you a brief idea, what we discussed. So, for every experiment that we perform, we refer or we keep a reference of something or we assume something at the very beginning, right? And that is nothing but we take it as null hypothesis. And then we also have an alternate hypothesis, meaning if the null hypothesis is not true, then we will refer that the alternate hypothesis is true, and then we will conclude our experiment in that way. So for performing experiments, there are various tests. These are statistical tests. So we have Z test, we have T test, students T distribution test, chi-square test, F test, T tests. Now, these two particular tests I will perform or I will teach you in later videos, not today, because I will be using directly the Python libraries to conduct these tests. And also, I will teach you some tricks how to basically know which test to apply when. Because ultimately, at the end of the day, you will deal with data sets, right? And though I will cover a few examples today, um, as you can see, I have listed down here quite a few examples that we'll do today. But then end of the day, you will be dealing with data sets, right? You will be dealing with data. So in those data, you have to perform this kind of tests, and you should know what test to apply when. So my forthcoming videos, I will teach you the tricks basically when to apply what test. Most of the data scientists and most of our beginners really find it confusing when to apply what. So don't worry, guys. I will teach that also. Also, one more thing. Since I said that I will be using Python libraries and all, before performing or before teaching this tests, I will also do a small crash course on NumPy and Pandas in Python. These are very important, guys. These are very important, and you should learn it if you want to do any machine learning problem statement. So I will, sorry, I will teach you this. Most probably, I will take few classes on NumPy and few classes on Pandas, and then we'll straight away start our machine learning algorithms and all. So this particular statistics, there will be, I guess, 2 to 3 more classes, and then I will wrap it up. Okay, and then from time to time, when it is required, I will, just upload one video on statistics. So let's start. So now there is a certain process. There is a certain process which we follow when we perform experiments. One is we define our null hypothesis. We define our null hypothesis. Also, we defined our alternate hypothesis. Pardon my writings, guys. If you are not able to read it properly, please let me know. I will try to improve. So, first of all, you need to define a null hypothesis. Second, you need to define an alternate hypothesis. Third, you need to know the confidence level. Now, you must know what confidence level is, right? Last class, I've discussed about confidence level, confidence interval. I've given an example, right? For example, if you're traveling from point A to point B, and you gathered some data, so in that, what will be the level of confidence that you will reach there at particular desired time? So you just go through my previous video to get an idea of what I am talking right now. So anyways, so for the experiments, so first of all, you need to define your null hypothesis. You need to define then your alternate hypothesis. You need to know your confidence interval. Fourth, you will have your decision rule. So based on your confidence level, you will have your decision rule. At what level you will accept your null hypothesis, or at what level you will accept your alternate hypothesis. So these are all the decision rules that you will take. And number 5 is you will perform the test. Perform statistical tests. So these are all the 5 process that you will do whenever you will perform any kind of an experiment, for to know something about a population, or to know something about the sample, or whatever it is. Okay, so you need to know, you need to do first of all these 5 processes. You need to define your null hypothesis. You define your null hypothesis. You define your alternate hypothesis. Then you set your confidence level. It may be 90%, 95%, or whatever may be. Right? Then you set your decision rule, and then you perform your statistics tests. Okay. So this is a small brief introduction of what actually we will do and all. Now there is something also called as type 1, type 1 and type 2 error. What are these? So in interview, it's a quite common question that they ask. Okay, tell me what is type 1 and type 2 errors. So type 1 error, type 1 error is when you reject your null hypothesis when actually it is correct. H naught is true. So while performing your experiments, you define a null hypothesis, right? And you define an alternate hypothesis. What if in the definition you assume it incorrectly? That will be a total blunder, right? So that causes type 1 error. In that case, it might happen that when you perform your tests, then you come to a conclusion that you have to reject your null hypothesis. So, but actually it is true. In that scenario, we call it as type 1 error. So remember guys, what is type 1 error? When you are rejecting your null hypothesis, H naught is denoted as null hypothesis. This I have already explained in my last video, right? So if you reject your null hypothesis, even when your null hypothesis is true, that is type 1 error. Okay. And what is type 2 error? Type 2 error is when you accept your null hypothesis when exactly it is false. When actually it is false, but even though you're accepting a null hypothesis, that is your type 2 error. That is your type 2 error. When actually it is false, but when you perform your test, You found out that it is true. Now how it happens, actually how it happens, it basically happens in your definition. When you are defining your null hypothesis, let's say, to give you an example, let's say I'm telling, for example, let's say the average salary in a company is 520k. Let's say it's too much, right? Never mind. Let's say it is 50k. Now, this may be your null hypothesis. Let's say there is an experiment. We want to know whether the average salary is 50k or not. And in the null hypothesis, you just mentioned it as this: the average salary is in a company is 50,000. So what will be your alternate hypothesis? Alternate hypothesis will be average salary not equal to 50k, right? This will be your alternate hypothesis, right? This is your alternate hypothesis and this is your null hypothesis. But actually, it is the reverse. Actually, according to the problem statement, what you should have done is you should have said null hypothesis as average salary not equal to 50, and alternate hypothesis as average salary is equal to 50. Maybe I'm just giving an example for you to understand. Maybe it is this: average salary not equal to 50k is your null hypothesis, and alternate hypothesis is average salary equal to 50k. Maybe it is the actual result, but what you have done is you have taken the reverse in your definition. You have said no, alternate hypothesis, sorry, null hypothesis, average salary is equal to 50k and average salary not equal to 50k is my alternate. If you do this, then you may result in type 1 or type 2 errors. So you need to be 100% sure whenever you're performing an experiment, you should be 100% sure what exactly is your null hypothesis and your alternate hypothesis. Because based on it only, guys, you will perform your statistics. Because these are all tests that you will do, right? And based on these tests, you will define, or you will conclude rather, whether your null hypothesis is correct or your alternate hypothesis is correct. So you know how crucial they are actually. So that's all about type 1 and type 2 errors. So let me go to the other screen and explain you some of the tricks basically that can differentiate, or you can know which test to apply when. So I already, as I said, that for this particular tests also I will give you some tricks. Now let me show you some tricks to differentiate whether you want to use Z test or student T distribution test. So let me go to some other screen. Now let me just write it down here. Z test. So when you will apply Z test, there are a few conditions that should met before you really apply this test. Number one is if your population standard deviation is given. If it is given, then definitely you will use Z test. Number two is if the population standard deviation is given and the size and the sample size maybe that is considered for this test is at least 30, meaning n should be greater than equal to 30. So whenever you are performing some tests, you will draw out samples, right, from that particular population. So that sample size should be at least 30. I guess 30 is not written properly. Let me write it down properly. Yeah. So the sample size should be at least 30, and the population standard deviation sigma should be given in the problem statement. If these two conditions are satisfied, then definitely you will go with Z test. Okay, now T distribution test. T distribution test, or you can also say it as student T distribution test. When you will apply this? When your population parameters are not given. Population parameters are not given. Meaning what? Meaning your sigma is not known. Sigma means standard deviation, right? It's also a population parameter. If it is not known, then definitely you will use student T distribution. Also, when your sample size is less than 30. In these two cases, you will use student T distribution, and in these two cases, you will use Z test. Okay, so please keep it in mind when which test to apply when. This is few tricks. Whenever you will see a problem statement, you try to find out whether in the problem statement the population standard deviation is given or not, and what is the size of the sample. If it is more than 30, definitely we will go with Z test. If size is less than 30 and population parameters are unknown, which in terms of sigma, then definitely we'll go with student redistribution test. Okay. Now we need to know the formulas. What is the formula for Z test and all? So the formulas of both of them are very similar. So the Z test formula is x bar minus mu divided by sigma divided by root n. N is the number of samples. Sigma is the population standard deviation. X bar is the sample mean. This mu is the population mean. Don't worry, guys. You don't have to remember this formula, but just keep in mind. Okay. Obviously, it is not like we are not superhumans, right? So we will not be able to remember each and everything. There are so many statistical terms. There are so many mathematical formulas that sometimes it's not easy for us to do or remember everything. So we will refer books or we'll refer sites. We'll Google to find out, right? So for now, just keep it in mind. Whenever you want to perform a Z test, this is the formula that we will use, where X bar is the sample mean. Okay, mu is the population mean. Sigma is the standard deviation. And n is the number of sample or sample size. This is the formula for Z test. Now, what is the formula for T test? Student distribution test. It is also same. It is also same. Here, the formula is like this. Instead of sigma, you will have S. What is S? S is the sample standard deviation. All the terms are the same. X bar is a sample mean, mu is the population mean, and instead of sigma, we have S. S is the standard deviation of the sample itself. Okay, here in this case, we don't know the population's standard deviation. We know the standard deviation of the sample, which we are taking out from the population. And n is obviously the sample size. So these are the formulas to calculate the Z test and the T tests. And we will refer, after calculating this particular thing, you will get a value, right? You will get a value, maybe let's say 2.96 or some value, some XYZ value, right? So how we will test or how we will conclude, we'll refer Z table in this case. I hope that you guys are remembering Z table, right? When we discussed Z score. So if you haven't watched my videos again, guys, it's a request. Please go back and watch the previous videos on Z table and Z score that I have discussed. And for this one, we will use T table. So there in the T table, in the Z table, we'll able to conclude, we'll have some area and all. I will show you all those things through which you can conclude whether you will accept your null hypothesis or you will reject your null hypothesis. It basically talks about the area under the curve, area under the region, all these tables. Okay, and it also has a degrees of freedom concept of degrees of freedom. Now, what is degrees of freedom? Right. Sorry, guys. So, what is degrees of freedom? Whenever you will refer as a T table, you will see that there will be term called degrees of freedom. So, whenever we will perform our experiment, right? So, if I go back to my first, so this is the process that we defined, right? For any experiment, this is the process. Uh, for any experiment, this is the process, right? So we'll have null hypothesis definition, alternate hypothesis definition, confidence level setting, decision rule. In terms of this student distribution, after decision rule, we also have to set or find out the degrees of freedom. Degrees of freedom. Now, I will tell you what exactly is degrees of freedom. What do you mean by degrees of freedom? Okay, so to explain you in very easy term, let's say there are 3 chairs in the office. Okay, now in one particular area, let's say. Now one person comes to the office. How many options do you think that guy have to sit? Now let's say these are all arbitrary places, arbitrary chairs, and anyone coming can sit in any chairs. Anyone coming can sit in any of the chairs. Let's say this is the first person that came in. How many chairs is available to him? 3. N is equal to 3, right? He can choose from 3. Now let's say he sit over here. Now a second person comes. How many options he have? 2, right? It's gone, right? 2, right? Let's say third person comes. How many options he have? It is filled. How many options he have? He has none, right? He has none. No. So till what time? Till what number the persons has some liberty to choose? Till second, right? If there are 3 chairs. So if n is equal to 3, then the number of freedom or the number of liberty to choose the chairs is 2, right? So if I say D O F, D of equal to 2, there's a till 2 he can choose, right? After 2, if the third person comes, then he will not have anything to choose from, right? Because he have to sit in here only. Now let's say I increase the number of chairs. Let's say 1, 2, 3, 4, and 5. Now let's say first person comes in. He will have option 5. So he can choose any one of them. Let's say he choose this one. Second person came in. Options how many? 1, 2, 3, 4. 4 options, right? Okay, so let's say he choose this one. Third person comes in. How many options? 1, 2, 3. Let's say he choose this one. Fourth person comes in. How many options? 2 options. Let's say he choose this one. Fifth person when he comes, does he have any option? No. He is only left with 1, right? He cannot choose. This is the only chair that is allocated to him. He has to sit here only. So out of this 5, how many degrees of freedom or how many liberty of choosing the chairs was possible? 4, right? So If n is equal to 5, DOF, degrees of freedom, was 4. So the formula is for sample size of n, degrees of freedom is given by n minus 1. Very important, guys. Remember this formula. Okay? Remember this formula. For a sample size of n, degrees of freedom is n minus 1. Now, sample size can be number of observations, number of categories. It can be anything. This one can be anything. It can be number of categories, number of samples, but degrees of freedom will be one less than that particular number. Why? Because we saw here, right? How we what are the liberty um, do we have to choose from? Think in that way. Then it will be easier for you to understand the degrees of freedom. So, guys, I guess couple of topics we covered today. Because I have to cover the hands-on also, so I will not go in further more topics, right? So we covered Z statistics, we covered student stage distribution, we know the formulas, we know where to look into the we need to look in the table to know about the problem statements conclusions. We talked about degrees of freedom, what is degrees of freedom, right? And I also told you the process that we will do by performing any experiment, right? And then I also discussed about type 1 and type 2 errors. These are all very important, guys. Whenever you will do any statistical tests in a particular data sets, you need to remember all these concepts. Though you will not use the same formulas because formulas are already there in library forms. So you will just call the libraries when you will do real data science problems. You will directly call the libraries. But this is important for you to know and understand how actually things happen, right? So why we do these tests? This is also important. Why we perform this kind of tests? Basically, we want to know the population parameters. We want to know how the population is behaving. Okay, where is the trend? Okay, statistically, can we prove it or not? That's why we perform those statistical tests, and there is a process to perform those tests. We have to define a null hypothesis, we have to define an alternate hypothesis, we need to know about the confidence level, how much confident we are, or also we call it as significance level, right? If you remember, significance level of or margin of error, right? And then we set our decision rules, and then we perform our statistics. Now, I might have forgot to tell you the formula for confidence interval. So let me write it down. Confidence interval. Interval. We talked about confidence level, right? We talked about confidence level. 90% confidence level, 95% confidence level, 97% confidence level, and all. We talked about margin of error in my last video. Margin of error or significance level. We talked about all these things, right? Now, also we talked about confidence interval, right? Basically, this is the nothing but the range, right? Now, confidence interval or CI is also given as this by this formula. Point estimate plus minus. You remember plus minus. Why plus minus? Because we are calculating a range. Plus minus margin of error. Now, this is the formula for confidence interval. Now, point estimate. If you remember, guys, I discussed about point estimate, right? Last time. So x bar was the point to estimate for a population parameter mu. When we discuss central limit theorem, there we saw, right, x bar was the point estimate for a population parameter. Point estimate means an estimator that estimates the population parameter. In our case, x bar is the point estimate for a population parameter mu. So here in this case, it will be x bar plus minus. Now, formula for margin of error. It is nothing but z alpha by 2, z alpha by 2 standard deviation by root of n, where n is the number of samples and sigma is the standard deviation. So this is the formula for confidence interval. This is the sample mean. Alpha is the significance level. Okay. So remember, just remember this, guys. Again, you don't have to memorize it. You don't have to memorize it. Just remember this formula: point estimate plus minus margin of error. Why margin of error? Why plus minus? Because confidence interval is nothing but a range from the mean, range from the sample mean, either this way or this way, and this is their mean. This is positive, this is negative. That's why x plus, or this way x plus, or x bar minus this way. It's basically a range. So this is about confidence interval. With this, I end this tutorial, guys, because I don't want to drag it further. So the remaining problem statements that we were supposed to do today, we will cover in my next tutorial. So today was all about the theory part of tests, T students T distribution tests, and confidence intervals formula and all. So it will be easier for you guys to solve the problems in the next tutorial. So that's it, guys. If you like this video, please click the like button and subscribe my channel, and please share it with others as well. Thank you. Keep learning and keep shining.